Imagine pushing the boundaries of science so far that you're not sure if the world will survive your experiment. For decades, physicists have been accused of tampering with forces too big to control, and sometimes those fears weren't unfounded. Today we're diving into very real moments in history when physics experiments left even the brightest scientists absolutely terrified. What if one wrong move in a lab could wipe out an entire city? That's what happened with the infamous Demon Core. In 1945 and 1946, scientists at Los Alamos were working on a plutonium core just under 14 pounds in weight, meant to be part of a third atomic bomb. This piece of metal looked harmless enough, but in reality, it was so unstable that the tiniest mistake could set off a deadly chain reaction. Two physicists, Harry Daghlian and Louis Slotin, both died from separate accidents while handling the core. Daghlian accidentally dropped a brick of tungsten carbide onto the plutonium, triggering a burst of radiation. Slotin made an even riskier mistake. He was using a screwdriver to hold apart two halves of a beryllium shell around the core. The screwdriver slipped. For less than a second, the plutonium went critical, unleashing a blinding flash of blue light. Slotin slammed the shell closed, saving the lab, but he absorbed a lethal dose of radiation and died 9 days later. The Demon Core was eventually melted down, but those incidents left everyone terrified. Physicists realized that in trying to study the heart of the atom, they had nearly unleashed another nuclear disaster on US soil. Before the very first atomic bomb was tested in New Mexico in 1945, some scientists feared it could literally ignite the atmosphere. The concern came from a terrifying calculation. What if the energy released from the fission reaction was enough to set nitrogen in the air or hydrogen in the oceans on fire? If that happened, it would trigger a runaway chain reaction that would engulf the entire planet. Theoretical physicists like Edward Teller raised the alarm, pushing Oppenheimer and others to recheck the math. Hans Bethe, a Nobel Prize-winning physicist, eventually proved that the reaction would stop before consuming the atmosphere. But the possibility was real enough that some scientists drove to the test site unsure if they'd live to see the sun rise. At 5:29 a.m. on July 16, 1945, the Trinity bomb went off. A blinding fireball lit up the desert, and for a moment, those watching thought maybe they had ended the world. Thankfully, the Earth did survive, but the terror in those moments was unforgettable. In 2008, when CERN prepared to power up the Large Hadron Collider in Switzerland, a new wave of panic hit headlines worldwide. The collider was built to smash protons together at nearly the speed of light, recreating conditions just after the Big Bang. Some scientists, and a lot of conspiracy theorists, warned that this could accidentally create a black hole. If it didn't evaporate instantly, it could sink into the Earth's core and swallow the planet whole. Lawsuits were filed in the United States and Europe to stop the collider from starting up. CERN issued a safety report showing that tiny black holes, if created, would vanish in trillionths of a second. But even inside CERN, a few physicists admitted that the possibility, however small, was unnerving. When the collider finally went live, people around the world watched to see if the Earth would survive, and I think we're still here. But for a brief moment, the largest physics experiment in history had the world terrified. In December 1942, in a squash court under the stands at the University of Chicago, Enrico Fermi and his team built the world's first nuclear reactor, known as Chicago Pile 1. They stacked layers of graphite bricks and uranium by hand, creating the conditions for the first controlled chain reaction. But here is the terrifying part. No one knew exactly how controlled it really would be. There was a real fear the reaction could run away, releasing deadly radiation into downtown Chicago. Fermi prepared controlled rods of cadmium to absorb neutrons, and as a backup, 3 graduate students stood on a platform above the pile holding buckets of cadmium salt solution. Their job was to dump the liquid into the reactor if things got out of hand. On December 2nd, 1942, the reactor went critical for the first time. Nothing exploded, and the world entered the nuclear age. But the fact that humanity's first reactor was built under a football stadium in a city of millions left many scientists uneasy long after the experiment succeeded. Not all physics experiments end with success. In 1999, at a uranium processing facility in Tokaimura, Japan, workers were mixing a batch of fuel for a reactor. Instead of carefully following protocol, they poured too much uranium solution into the tank. This mistake caused the mixture to go critical. A bright blue glow filled the room as gamma radiation blasted out. The workers nearby were hit with massive doses of radiation. 2 of them suffered agonizing injuries and died after months in the hospital. And what terrified scientists was how quickly things spiraled out of control. The chain reaction kept restarting for nearly 20 hours, forcing emergency crews to improvise ways to stop it. For many physicists, this was a very sobering reminder. One simple mistake in handling fissile material could trigger a disaster worse than any lab is prepared for. At the bottom of Siberia's Lake Baikal, scientists set up an experiment in the 1980s to study neutrinos, tiny particles that pass through everything, including the Earth itself. To do this, they lowered an array of sensors deep under the frozen lake, but once the experiment went online, something terrifying happened. The detectors started picking up signals they couldn't explain. Bright flashes of light lit up the water, sometimes in patterns too regular to be random. Some scientists speculated about new physics. Others whispered about UFOs, since locals around the region had long reported strange lights in the lake. For years, the unexplained events haunted the researchers, leaving them unsure if they were looking at particle interactions or something far stranger. While the Baikal telescope continues to operate today, those early mysterious flashes remain one of the most unsettling moments in neutrino physics. In July 1962, during the height of the Cold War, the US military decided to see what would happen if you set off a hydrogen bomb in space. They called it Project Starfish Prime. At 250 miles above the Pacific, the bomb exploded with a yield of 1.4 megatons. The explosion lit up the night sky like daylight, but what terrified scientists was the aftermath. The blast created an artificial radiation belt around the Earth. Satellites started failing one by one as radiation fried their electronics. Even months later, the artificial belt was still there, circling the planet like a man-made hazard. For physicists, this was a nightmare. They realized they had permanently altered near-Earth space with one single test, and no one knew if it would last decades or even longer. The fear of accidentally destroying satellites or even the ozone layer made future space tests extremely controversial. On September 22, 1979, an American Vela satellite detected a strange double flash over the Indian Ocean. These flashes were the unmistakable signature of a nuclear explosion. But here's the problem. No country admitted to conducting a test. Some scientists believed it was South Africa and Israel secretly detonating a nuclear device. Others thought it might have been a meteoroid hitting the satellite or even a glitch in the sensors. The uncertainty terrified the scientific community because if it was a real test, it meant the nuclear club had just expanded in secret. But if it wasn't, then a reliable satellite system had failed at the worst possible time. Decades later, the Vela incident is still debated, and the fact that no one could explain it left physicists deeply unsettled. In the 1980s, the United States began building what was supposed to be the largest particle accelerator ever, the Superconducting Super Collider in Texas. It was designed to be more powerful than CERN's Large Hadron Collider, but as construction began, concerns started to spread. Some feared it could create exotic particles that might destabilize matter itself. Others worried it could trigger events nobody had ever seen before. Rumors swirled in the media that the machine could destroy the planet. Ultimately, the project was canceled in 1993 due to cost overruns and politics. But for scientists, it left a chilling thought. Had it been built, we might have been running experiments that went far beyond anything we've dared to attempt since. Not all terrifying physics experiments involve nuclear bombs. Sometimes they involve the question of whether we're alone. In 1977, while scanning the skies with the Big Ear radio telescope, astronomer Jerry Emmon recorded a 72-second signal unlike anything ever detected. It was strong, structured, and came from the direction of the Sagittarius constellation. On the printout, Emmon circled the signal and wrote "Wow" in the margin. For weeks afterward, scientists tried to detect it again, but the signal never reappeared. The possibility that it came from an advanced extraterrestrial civilization was both thrilling and terrifying. If aliens were signaling us, it meant humanity had just brushed against something far beyond our understanding. And if it wasn't aliens, then the fact that no one could explain it left astronomers and physicists equally as uneasy. Alright guys, that has been our list for today. Thanks so much for checking it out. I've been your host today, Olivia Kozlowski, and I will see you again soon. Goodbye.